All right, as I mentioned yesterday in class, this unit is going to have a lot of proofs on it. Okay, and the proofs are primarily, at least, going to be using stuff that we have done prior to this unit. So we're going to go back and review the things that we've done prior to this unit that are likely to be used on this unit. Okay, you'll see all of these things recurring over and over again in proofs on this unit. So remember that in a proof, you make a series of conclusions, which are called statements. Each one of them, we give a reason for that statement, and that reason has to be a definition or a property or a postulate or a definition. Here are some of the most common ones. So, first of all, if all you've got is a diagram, and you've already used up all of the given, but you still haven't gotten where you want to go. This happens a lot. In about half the problems, you will have this first one, and in the other half, you'll have the second one. Almost every problem that we do in this unit will have one of these two things going on. So, in this first one, is there anything that you can see that you know are congruent? Yes, Madeline. Yeah, the vertical angles. Can you name them for me, please? Yes. So our statement will be that angle TXE is congruent to angle AXS.
You have to make that chart.
No, we're just making a single statement with a reason. We're not doing a whole proof here. These are going to be part of proofs.
So part of proofs is going to be like single statements?
Your what?
Like a part of proofs is going to be like single statements? Like a test?
No, a proof is made up of a series of statements. Right now we're just doing one. We'll work our way up to doing more. Our reason for this is because vertical angles are congruent. If you would rather for that, you can write the vertical angles theorem, and I'm okay with that. But it's such a short theorem, I usually just say the theorem. Vertical angles are congruent. Okay, again, that's going to come up on about half the problems. If you can't see and identify correctly vertical angles, this unit is going to go very, very, very badly for you. Okay, vertical angles are important. Now, on this one, this is an example of the one that I told you about on your homework where I said, yeah, I didn't tell you about that in advance. On this diagram, notice that you've got these two triangles that are kind of stuck together. What side do they share? AN. So our statement is going to be that segment AN is congruent to segment AN. Yes?
I got a question. If AN is like a bisector?
We don't know that it's a bisector, though. It looks like it is. It also looks like this is perpendicular, but we don't know that either.
So how do we know if it's like a bisector?
It will tell you in the given.
So if it is a bisector, does that mean segment AM is congruent to segment AT? If it was a bisector?
No. If you had an angle bisector, you would know that these two angles are congruent up here.
But the two segments aren't?
Not necessarily. And our reason for this, and again, this is new, is the reflexive property. And I'm not super mean to people about their spelling, but I will say on this, if you call it the reflective property, I'm going to ask you if it's shiny or not. It's not the reflective property, it's the reflexive property. Like a reflex action. Like you may have never had it done before, but you do the deal where you at the doctor's office you sit, you cross your legs, and he hits you with like a hammer or something right below your kneecap, and your leg jumps out. That's a reflex. Okay. Now,
Wait, why? No.
so when we mark it, normally when we mark segments congruent to another segment, we just put a little slash across it, right? But if I just put a slash across this, you're going to go, well, where's the other one? Right? So what we do instead is that we mark it with a slash and then with another slash going the opposite way. So that I'm saying this segment is congruent to itself. That X almost also should remind you that it's the reflexive property, not the reflective property.
There's both things.
No, the reflective property is not a thing.
Or reflexive.
Says that something's congruent to itself. So if you put reflective property, it'll be wrong. Okay? All right. So again, going back to things that we did earlier this year, perpendicular lines. The definition of perpendicular lines is that perpendicular lines are two lines that intersect to form right angles. So this, and you might want to add that, that's the definition. Of perpendicular lines. That's the definition of perpendicular lines, that they make right angles. So here, if we know that segment AG is perpendicular to segment SL, well, then they're going to make right angles. Keep doing statements, just statement. So our statement here would be, well, where are the right angles?
In the middle, like where A is.
Okay, so what would the name of those two angles be?
Angle GAS.
Yeah, angle GAS. And,
How we know?
go ahead.
I was gonna say, doesn't even need to be a bisector for it to be a right angle.
No. To be a right angle, you have to have perpendicular lines. So those are right angles.
And we know this perpendicular lines
Because it was given. And our reason is going to be the definition of perpendicular lines. Yes, sir.
What's that after, before statement? Like the
Where? Here?
yeah.
That's RT. That's how I abbreviate right.
Oh.
Yeah, if you ever have trouble reading my handwriting, I'm not offended. I use a lot of abbreviations and I don't always write very neatly.
Okay, that's the reason.
Yeah. The reason was definition of perpendicular lines. Okay? All right, let's go on to the next page. If you are given right angles, there are always two different things that you can do. Which one you actually want to do in a proof depends on the proof. It's never wrong to do both, though. So we're going to practice doing both. So, if a triangle contains a right angle, that triangle is a right triangle. That is the definition of a right triangle. So, if O and T are right angles, the statement that we can make is that triangle NOR and triangle HTR are right triangles. And our reason for that is the definition of a right triangle. Now, notice on this next one, the given is the same and the diagram's the same. But remember, I told you a second ago that there are always two things you can get from right angles. So if these are both right angles, are they both the same size? What do we call angles that are the same size? Congruent angles. So our statement for this, and again, when you're doing proofs, if you're not sure whether to say you have right triangles or to say that those two angles are congruent, then do both. It's never going to be wrong. Angle O is congruent to angle T. The reason for this, and this is the last new thing that we're going to do today, we've never actually said this before, but I think it's pretty obvious. All right angles are congruent. Tyler, Bronson, and Bronson? I puzzled that one out. So it's Tyler Blossom. So is it Bronson something that starts with a B also?
Yeah, they both have Bronson B's, so they have to say their last names.
So what are their last names?
One is, I don't know. One of them is my brother's friend, but I forgot his last name.
Okay. I was just curious. So they're both BBs?
Yeah.
Interesting. All right. Any questions about that? So when you have right angles, there are two things you can do. Say that you have right triangles or say that they're congruent. Either one of those is fine. You'll never need both in a proof, but if you don't know which one to do both. All right. Next, again, going way back, angle bisectors and midpoints. That's stuff we did near the beginning of the year. So here, remember that a midpoint divides a segment into two congruent segments. That is the definition of a midpoint. Midpoint divides one segment into two congruent segments. You did some of these on last night's homework. If A is the midpoint of segment LN, you should all be able to make this statement. If A is the midpoint of LN, what's going to be true? And when you say segment LA is congruent to segment AN. And your reason for that is the definition of midpoint. Yes, sir.
How come is A is the midpoint for L and N is not the, how come it's not the midpoint for that segment?
Midpoint for what segment?
Because you see how A and D are segment?
Segment AD?
Yeah, yes sir.
Yeah?
So that wouldn't make L, D, and D, N congruent too?
Nope. Because it's the midpoint of segment LN. So LN is what's getting cut in half. Okay? All right, let's move on. Page 3. An angle bisector, very much like a midpoint cuts a segment into two congruent segments. An angle bisector cuts an angle into two congruent angles. They're almost exactly the same thing. This is the definition of angle bisector. Colton, you okay? Oh, gotcha. On these problems, you have to be really careful about what is getting bisected. So here it says segment CU bisects angle OCG. OCG is this big angle over here on the left. So whatever you do, don't tell me anything about any of these angles over here on the right. Okay? So for my statement, if I know that I'm bisecting OCG, I'm going to cut that angle in half. What are the two halves?
Right angle.
OC what?
OCU.
Yep. OCU is congruent to angle GCU. Those two angles are going to have to be congruent. My reason is the definition of angle bisector. Yes, sir. Yes.
So do we cut the GCO and do we cut the GCO in half? Or
We cut OCG in half.
So did I just cut what a C is, or like?
Yeah. Here's the angle OCG, and then segment CU does the cutting.
So UCO and UCG are not correct?
UCO, yeah, UCO is the same thing as OCU. Okay, so either way you want to say it is fine. All right. Last thing, and then we're going to practice all this, is what if you start off with parallel lines? We know a lot of things about parallel lines. We're not going to use all of them. The two that we use almost always is the alternate interior angles theorem and the corresponding angles postulate. Almost always it's one of those two. So, for this one, if we're given that PL is parallel to NA, you got to pay attention to which lines are parallel. Otherwise, you may give the wrong statement. If these two are parallel, then what two angles do I know have to be congruent to each other? PLN is congruent to what? LNA, okay. These two angles are congruent to each other.
How we know that?
Good question. I was about to ask the same thing. How do we know that? Yeah, it's the alternate interior angles theorem. When lines are parallel, alternate interior angles are going to be congruent.
What are the alternative angles?
There are none in this picture.
But if they are, would they be congruent too?
Yes, but we almost never have those in this unit. I think I may have one problem in the whole unit that has them. By the way, are these two angles alternate interior angles also? Those two that I just marked with an X?
Yes, sir.
Do I know they're congruent?
No, because they don't have the line.
Yeah, we don't know that these lines are parallel, so we don't know those are congruent. You got to pay attention to which lines are parallel. And then AS is parallel to GE. So AS parallel to GE. I need to be able to make a conclusion based on that, a statement. Yes, Cameron.
Angle EGS is congruent to angle GSA.
Yes, that's true. It's not wrong. It just doesn't help me a lot with the two triangles, but you are correct. Okay? Yes? ASG to SG. That's the two he just talked about.
Oh, sorry.
Okay? Sierra?
Angle IGE is congruent to angle GAS.
Yes. These two angles are congruent. Angle IGE is congruent to, she called it angle GAS, but do you have to name it with all three letters for A? No. Did I have to call this one IGE? Yes, because if you say angle G, no one's going to know which angle G you're talking about. And Sierra, did you get a reason for that?
I said corresponding angles.
Perfect. Corresponding angles postulate. Okay. So we have gone through an example of every single type that's common. Now we're going to go through them again, except this time I'm going to have you try and figure them out. I'll give you about a minute for each. I'll give you a little bit of time to talk to people around you. And then I'm going to use a random number generator to pick who gets to answer it. So when you talk to somebody, find somebody smart to talk to that's nearby you so you don't have to get up or talk across the room.
We're close. We're close.
You're not close enough.
Not like me and Muriel. We are far away, but me and we're close.
No.
We're not yelling at them.
So find somebody to talk to after you have tried one. So be sure, it says for each of the following, write a statement/conclusion and the reason based on the diagram and the given information. So don't tell me something that's true that's not based on what was given. Okay? There are several things that are going to be true. But here, the given, A is the midpoint of segment CM. Write what you think would be a statement for that and give a reason for that. I'm going to give you about a minute. Go.
You want to just do that one? Or?
Just do that one for right now. I guess if you really want to go ahead, that's fine, but if you need help, you can look back. You can talk to somebody nearby you for the next 30 seconds, and then I'm going to call on people randomly. So check with someone smart near you or look back. And just so no one accuses me of cheating, I'll show you the random number generator I'm using. Pick a number between 1 and 16. Oh, by the way, if it picks a number where there's nobody sitting there today, you guys get to pick who does it.
Like the class?
Sure.
Or like a person?
Let's pick Bria every time.
Please don't.
Yeah, let's do that.
All right, who's in desk 10? All right. can you tell us what you gave for your statement and what you gave for your reason for this?
Statement, segment C, A, is congruent to segment A.
Excellent. That's exactly what you should say. And for your reason?
Definition of midpoint.
Perfect. Yes, sir.
It had to be a segment.
It did.
Can you explain like how that works?
Because if you cut a segment in half, you get two smaller segments that are congruent to each other. So it starts off telling you it's the midpoint of segment CM. So we start with the segment, cut it in half, we get two smaller segments that are congruent to each other. That's what a midpoint does. It divides one segment into two congruent segments. All right, everybody take a look at the next one. Again, if you need to look back at your previous examples, do it. That's why you have your previous examples. All right, check in with somebody nearby you. See if they agree with what you have. Some of you aren't checking with anyone. If you check with someone, you can. If you get it wrong, you're like, oh, well, that's what someone told me.
Oh, okay.
Number 4.
Okay, angle SMT and angle SMN are right angles, and the reason is definition of perpendicular lines.
Very nice. Angle SMT and angle SMN are right angles. And always practice marking the diagrams because that's going to be important to us because of the definition of perpendicular lines.
I thought right angles like were congruent to both fits.
Wait. Hang on, one at a time. What?
I thought aren't both right angles like congruent?
Yes, if I know the right angles to start with, but I didn't know they were right angles to start with. I started off knowing that I had perpendicular lines. From that, I know I'm going to have right angles. That's the definition of perpendicular lines says that perpendicular lines make right angles.
And they make right angles, so once they make right angles, won't they be congruent after?
Yes, after that, in a subsequent step, yes.
But
So for this, that's all we can say in this one step. We're only doing one step. We're not doing two, one step.
definition of
Perpendicular lines. All right, take a look at the next one. See what you can do with that.
can you go back up? Or did you already delete it?
Pardon?
Can you go back up or did you already delete it?
I already deleted it. I can rewrite it for you if you like.
Angles? Huh? we have to put like that? 'Cause I put TMS in NS.
That's fine. All right, if you haven't already, discuss with somebody nearby you what you could write for this.
What's the name? Alt
Angles theorem. All right, let's see. 16, Emiliano. What did you put for a statement?
I didn't know if this was correct. I put GHO is congruent to OTS.
Wait a minute, you said GHO
Yeah.
is congruent to what was the other one?
OTS.
Look again.
GHO.
GHO is here.
GHO. OFT.
There you go. Angle OST.
And reason was corresponding with postulator.
Oh, but these are not corresponding.
Oh.
Help them out, you guys. What is that? Alternate interior angles. So it's the alternate interior angles theorem.
So we have done it the other way?
What do you mean the other way?
Like G and T?
Yeah, absolutely. So let's add that. Angle G is congruent to angle T. And we'll mark those with 2 arcs.
Wait, so, okay, I put OGH is congruent to T. G, wait.
You put OGH is congruent to what?
No, I put OGH is congruent to TOS.
No. TOS has its vertex at O. TOS is this angle right here in the middle.
I meant to put it as OGH is equivalent to OST.
No, OST would be over here. Remember, the middle letter has to be the vertex of the angle. So if you're saying OGH, you would say OTS. Okay? All right, let's turn the page. On this one, just the diagram, nothing else. Micah doesn't so much have conversations. He's like, yeah, that's my answer. You're a man of few words?
No, I'm just tired.
Okay, fair enough. All right, talk it over with somebody nearby you. Make sure everybody nearby you has the right answer. If somebody nearby you, I call on them and they don't have the right answer, and you didn't help them out, I'm coming after you.
Yeah, that's very loud. That was very distracting.
All right. Anybody not ready? All right. We'll wait a moment. The thing I like about this.
I went to the restroom. Just very quick stop.
Yeah, you can get this back after school today, not before then. Pardon?
Are we on the homework yet?
No.
No.
Number 12. No one sits in number 12, so you guys get to pick.
No, that's not fair.
She's already gone, so you have to
Let's
pick somebody else.
Rivers. I pick Rivers. I pick Junior. Junior.
Bro, y'all should have said 3 different names and only 2 people said something. Y'all are a class for a reason.
I think Junior.
So-
Junior knows the answer.
Junior.
No, go ahead.
Junior's
Rivers said she would do it, so your eyes said you would do it. Thank you.
AOJ is congruent to COJ.
So, what did you call it? The angles? So you said, did you put the angle symbol?
Yes.
So angle AOJ is congruent to, what was the other one?
COJ.
So be sure you're putting the angles in front of those. And what was the reason?
Vertical angles are congruent.
Perfect. Vertical angles are congruent.
Mr. Davis,
Yes.
are vertical angles not a theorem? It's just
You can write the vertical angles theorem, and I would take that. I usually just write it because it's so short.
So vertical angle theorem, you take that?
I just said that. All right, take a look at the next one. Again, just using the diagram.
Okay, I'll just stop laughing because you don't want to laugh. You don't laugh. Wait, stop. I'm not
And I swear, it sounds just like this.
Who?
All right, if you have not already, check with somebody nearby you.
All the flakes is, I thought it was perplex. That joint was hard.
Yeah, at least you figured it out.
All right,
Merry Christmas.
Junior,
Merry Christmas.
what do you have for your statement and reason for this?
X is congruent to
Exactly. And what's the reason? Very good. The reflexive property. I tried to remind you that it was reflexive property by putting an R and an X in it.
Oh, so
That did not work.
that was so helpful, Mr.
Thank you, Mr.
Davis.
Davis.
No, it don't.
It helped
Wait,
me out
listen,
so
why did you
much.
just put the X?
It
On
don't.
RX.
There is an X in RX.
Yeah, you should. You goofy. What he just did is what I meant.
Oh.
Word.
All right.
Let's give a cord in this fucking.
So, for number 6,
Oh God.
there are actually 2 different statements you can make from right angles. We did an example. If you need to look back, look back. But I want both of them.
Oh,
Both of them.
Yep.
I think there's a word.
Sierra.
After I just said, there are 2 things that you can do.
No, but like, you could have made a mistake today.
I could, but not on this.
They both gave me the same name.
Where are your 2 different ones?
Because you did the same statement and the same reason. You did the same thing twice. Wait, that's a problem.
No, stop.
You did the same thing twice. That's a problem.
All right, let's see who we're going to pick on this
I
time.
hope it's you're a lame. You're a lame. Why would you-
Bria?
No.
Yeah.
No. Okay, well, can I give one and somebody give the other?
Yeah.
Oh, okay. So, actually, I'm not sure.
you got it. Believe in yourself, and you can.
Wait a minute. I gave you time to talk to somebody. This is not the time to look on someone else's paper. This is the time to tell me what you have. Tell me what you got.
No, okay, wait. I literally just wrote the given again.
You wrote angle CAS and angle TAS are right angles?
Yes.
All you have to do is change it ever so slightly to make that a correct one. But,
Segment SA.
no.
Okay.
I already picked on Emiliano a minute ago.
No.
Yeah,
Yes.
Maddie.
Believe in yourself.
Don't
Yeah.
even. Use your own advice.
Wait,
Okay.
Mr. Davis.
Yes?
But okay. Number 6 is the right angle one, and number 8 is the right angle one, so you have to put both for that.
It says do something different.
All right, we'll get just do both for both. Yes.
Okay.
Working ahead.
That is.
Yes. Go ahead.
That is not.
Angle.
Shh. quiet, please.
Triangle CAS and triangle TAS are right triangles.
Yes.
Definition of right triangle.
Very good.
Okay.
Okay, Bria, you should be fixing yours instead of complaining about it.
I did fix it.
You fixed it?
I think maybe we should take a look at your paper.
Okay. Come look at it.
Yeah, you're fixing it
All
now.
I had to do was like add a little
Okay.
extra line.
Yeah. That's what I said. Fix it.
I did. I just fixed
Okay.
it.
You said you already had. Yeah, I don't like being lied to. All right, so I need somebody else for the other one. Let's see. Number 1.
I have angle CAS is congruent to angle SAT.
Yes. And what's your reason?
All right angles are congruent.
Very good. All right angles are congruent.
Could you do segment SA perpendicular to segment CT?
That's a third thing that you can do. We're not really interested in it, but you're absolutely right. Okay, any questions about this one now? All right. Only a few more.
Wait, do we actually have to do number 8?
Well, we haven't done number 7 yet, so
Do we?
yes, on number 8, do both. I know, I'm killing you. It just absolutely kills you.
Seems a tad unnecessary.
So do them both again, and maybe Bria will get them right this time.
Stop.
Well, never mind. I'm not gonna tell you.
Hey, I learned from my mistakes.
Anaya, have you done number 7 yet?
Why would you assume that I haven't done number 7?
Because I know that you haven't, because you've been talking.
That's false.
Now, no, you were talking about number 6.
False.
You weren't talking about number 6?
I mean, yeah, yes, I would. I would.
You said false.
No, I'm not sure. I'm not sure.
And I also went to a binder.
What's up with your area? Thank you.
I would donate you a new binder.
Please, dude. This one's
It's
struggling.
like falling apart.
Oh, you know, tough times. Budget cuts.
From the Christmas.
From what?
Budget
It's almost Christmas time, you know, we gotta save money.
All right, check on the people around you. Make sure they have the right answer. Cameron, wake up. In a moment, I will call on somebody. All right, Colton.
Oh, dang it. I said triangle RTE is congruent to triangle ATE.
Not triangle, but
Triangle.
okay. Angle RTE is congruent to
KTE.
because
I was gonna say corresponding angles.
no.
Then I don't know. Bisector angles, something.
Definition of angle bisector.
Yeah, that.
All right.
So if I were to say triangle, TRE, and triangle, TE.
It's not triangle. It's angle.
No, I'm asking. Those two aren't congruent because I thought that.
To have congruent triangles, all the matching sides and all the matching angles have to be congruent. We don't know any of those things.
Oh,
Okay? All right. Look at number 8. Do the same thing you did on number 6, not the different thing that you did on number 6.
something different than six.
Ignore that, which is what I just said. Do the same kind of thing you did on number 6. So you should be able to look back at number 6 and it should help you out.
There's not going to see. You just say you're deaf. You be hearing everything.
I hear a lot.
Yeah, you be hearing
I just don't
everything.
always understand what I hear. It's not that so much. But if there's more than one conversation going on, I can't parse them at all. It's just one big garble.
That's how we doing those statements and reasons. Okay.
Yes. Okay, again, check on somebody. Make sure everybody's ready. Bria, talk to the people near you. Near. That means adjacent to you, not across the room. So check on Garrett. And then check on the person sitting beside you as well. He might want to know.
What do you have to do? And then the other one.
Is anyone not ready?
That's bullying. That's bullying.
Like what?
Word.
Number 12. This time I get to pick. Who haven't I picked? Who hasn't done one yet?
That's not true.
Anayo.
Bro, whoa,
Yeah.
chill. It's not pick a knife,
Jeffrey
man.
and one.
Sierra.
Jeffrey has not done one.
She did one.
Go ahead, Jeff.
Sierra, tell me what's one of your statements and reasons.
Angle D is congruent to angle A because right angles are congruent.
Yeah. Let's say all right angles are congruent, but yes. Good. And it keeps picking Emiliano over and over and over again. Number 11. Carson, is that you?
Triangle DYN and triangle NAC are both right triangles. The definition.
Very good. Triangle DYN and triangle NAC are right triangles by the definition of a right triangle. A good what? All right, let's look at this last one. We've got parallel lines. See what you can do with it. So who's going to get picked? Dun, dun, dun.
Hopefully Anaya.
Not A.
I'm just gonna look.
We'll just keep going till we get someone who hasn't done a whole bunch.
Cameron. That's Cameron.
7. Cameron, you haven't done a whole bunch. All right. Tell me, Cameron. Gentlemen, shh. Go ahead, Cameron.
My statement is angle AGN is congruent to angle E because of the corresponding angles postulate.
You are correct that we're going to use corresponding angles, but you have the wrong 2 corresponding angles. It's these 2 lines that are parallel.
Oh, wait.
You didn't like the other 2 lines were parallel. You want to try again?
Is it angle A and angle B?
An angle what?
An angle L. An angle LG.
Yep.
Across through the lines too.
So these 2 angles are congruent to each other, and that is by the corresponding angles postulate. Okay. Your assignment is a worksheet. I'm going to give that to you right now. I expect you to work